Okay, similar figures. Similar figures. Similar figures have the same shape but not necessarily the same size. Boy, that sounds familiar. Something else you should know, that corresponding angles are congruent and the corresponding sides are proportional. The proportion is known as our scale factor, which is often given as the letter K. Dilations create similar figures. You knew you heard this stuff before, right? Hopefully. So what does that mean, corresponding sides and angles? There's the definition here and an example down at the bottom. Just because the figures have different letters, they're in different locations, even different orientations, we should still be able to figure out the corresponding sides and angles. So it's pretty easy when they're next to each other and they're facing the same direction. But let me show you some ones that might be a little bit trickier. You should still be able to figure them out, though. Alright, so the two figures could be rotated from one another. And in this case, it's actually rotated and reflected. So the best thing that I have to tell you to deal with that is figure out which sides are the different lengths. So we have shortest, middle, longest. Usually we're going to be doing a lot of work with triangles. But if you had 4 sides, make sure you think about all 4. So I would match up 10 with 12, 15 with 18, and 20 with 24. You might see the two figures are embedded in each other. So for both of these, A is at the top, and then we have, so let's see here, if we have APQ as our small triangle, and then we have ABC as the big triangle, let's look at our coordinating sides. AP would correspond to AB, AQ corresponds to AC, and PQ corresponds to BC. And then angle A corresponds to itself, P corresponds to B, Q corresponds to C. So let's ask ourselves, are the figures similar? So let's start off, we know that the two figures are rectangles, that's given to us, so we know that all of the angles are congruent. That's the first part. Are the angles congruent? Yes. And then are the sides proportional? Are the sides proportional? So let's see, let's do the shortest to the shortest, 5/10. And let's see if that's the same thing as taking 8 to 13. Well, 5/10 reduces to 1/2, but 8/13 doesn't. It would have to be 8/16. So this does not equal 1/2. Doesn't matter what it is, all I know is that the sides are not proportional. So, big fat no here. Let's look at these. Well, alright, do we have congruent angles? And we have 40, 40, 70, 70, 70, 70. Yes, we do. Do we have proportional sides? Well, I have my shortest sides, we go 2 to 1. And then the triangles are isosceles, so we have 4 to 2 and 4 to 2. Notice, alright, second example, are they similar? Well, we have two criteria here. Are the angles congruent? And are the sides proportional? Alright, so the angles congruent part, 40, 40, 70, 70, 70, 70. Yeah, that one was easy. It's not always that easy, but in this case it was. Then let's look at the sides. We have the shortest sides, 2/1. So I went big triangle to small triangle. That's important. Pick an order. I could have done 1/2. If I went small triangle to big triangle, just pick. So we do 4/2 and 4/2. By the way, these two triangles are isosceles because they have two pairs. They have a pair of congruent sides. So if I wrote it the other way, it would look like this. And they all reduce to the same number. Those all reduce to the number 2. Those all reduce to 1/2. So if I picked, so yes, the sides are proportional. Yes, they are similar. If I went from KLM to EFG, the scale factor would be 1/2. If I go the other way, the scale factor is 2. So think about some things to write down for your summary, maybe what makes two figures similar, and what are the corresponding parts. And brace yourselves because ratios are coming.